Beams are the horizontal members of a structure which are provided to resist the vertical loads acting on the structure. So in order to maintain the efficiency of a structure, it is necessary to provide the proper size of a beam to resist a given set of loads. The size of a beam, that is depth and width, depends upon the length available for casting the beam. For calculating the depth of a beam using the thumb rule, we use the formula depth of beam equal to L upon 10 to L upon 12, where L is the clear span of the beam. By the term clear span, we mean the column inner to inner distance. For illustration, let's consider a beam having a clear span of 6 meter. The depth of this beam will be given by depth equal to L upon 10 or L upon 12, that is 6000 upon 10 or 6000 upon 12, which will be 600 mm to 500 mm. Hence, we can choose any depth between 500 mm to 600 mm for a 6 meter clear span. Let's take another example of a beam having a clear span of 3 meter. Its depth will be given by depth equal to L by 10, which is 3000 upon 10 equal to 300 mm, or L by 12, which is equal to 3000 mm upon 12, which will be equal to 250 mm. For calculating the width, the ratio of width to depth should be greater than 0.4 to 0.45 as per IS 13920. That is, W by D should be greater than 0.4 to 0.45, where W is the width of beam and D is the depth of beam. It should be noted that the minimum depth should be kept as 200 mm. For illustration, if we have a beam of clear span 3 meter having a depth of 3000 upon 10 equal to 300 mm, and let's provide the width of this beam as 200 mm. The ratio of W by D will be equal to 200 upon 300, which will be equal to 0.66, which is greater than 0.4. Hence, it would be safe to go with 200 mm width for this beam. Let's take another example of a 6 meter span. The depth will be given by 6000 upon 10, which is equal to 600 mm, or 6000 upon 12, which will be equal to 500 mm. Let's choose 550 mm as its depth. Now let's provide the minimum width equal to 200 mm. The ratio of W by D will be 200 upon 550, which will be equal to 0.36, which is less than 0.4. Now let's increase the width to 250 mm and check whether it's safe or not. The ratio of W by D will be equal to 250 upon 550, which will be equal to 0.45, which is greater than 0.4. Hence, it would be safe to provide 250 mm width for this beam. So this was all about this lecture. If you like my content, please subscribe my channel and don't forget to press the bell icon so that you don't miss any updates in future. Thank you.